Ah, welcome. I thought it might be useful to take some time and really work through several problems and the thought process behind how to select the correct acceleration equation in a given circumstance. This is really going to be an explanation on the process and review some of the key information that you need to know before you even start reading a problem. I want to just take a minute right now and emphasize some units. This is critically important, but I want to make sure that we understand that we cannot go through this whole process if we do not understand what these symbols mean. So in the equation, whenever you see distance, that's going to be represented as a d. The unit for distance is meters, m. So units are what's in the word problem. So when you read the question, this is what you're going to see in the word problem, okay? And they represent these symbols here. So we just have to know this. Time is, of course, measured in seconds. Both speed and velocity are measured in meters per second. Of course, velocity would have a direction, speed may not. And acceleration is meters per second or meters per second squared, typically. We have to know these units so well that when we see them, we can immediately identify them. Which leads us to the equations. And it's actually not a lot of equations. And I'm going to break it down really simply. I'm going to break it down into the no acceleration and the acceleration. Because fundamentally, the issue here is if you have an acceleration, you have to use different equations than if you don't have an acceleration. So let's break this down. If you do not have an acceleration, if you have no acceleration present in the problem, you don't see the unit meter per second squared, it doesn't say accelerates or anything like that, you are relegated to using the speed triangle. There are 3 equations that come from this triangle. This is it. These are the equations. Speed equals distance divided by time. Distance equals speed times time. And time equals distance divided by speed. That's it. It's all really one equation. It's just algebraically manipulated. The speed equation. So if you have no acceleration present in a problem, you're going to use this. If you do have an acceleration, however, we only have 3 equations to work with. Acceleration equals final velocity minus initial velocity divided by the time. We also have v equals at, velocity equals acceleration times time, and distance equals 1/2 at squared. That's it. So does that mean, when I look at these equations, that this is the only equation that solves for acceleration because it says a? Or this is the only equation that solves for velocity? No, not exactly. Because while those are, in fact, that is acceleration and this is velocity, we have algebraic skills and can manipulate these equations to solve for other things. As for now, we will not manipulate this equation. We're going to leave this equation alone. That'll be later in the year, not yet. But these 2 equations could be algebraically manipulated to solve for any of the 3 variables in them. You can use this first one to solve for velocity, of course, but if you have 2 of the 3 variables, you could solve for the missing one. So you could use this equation to solve for acceleration or time. You can use this equation down here to solve for distance, of course, but you could also use it to solve for acceleration and time. So what does that translate to? It translates to this. If a question says how fast, what it means is it's looking for either speed or velocity. If it's looking for speed, you're going to use speed equals distance divided by time. If it's looking for velocity, you're going to use velocity equals acceleration times time. Simple. So, okay, if it says how fast, I'm going to use either this equation or this equation. That's right. Well, how am I supposed to know which one to use? One has an acceleration, one does not have an acceleration. So that's how you further differentiate it. Similar differentiations will happen with how far. If it says how far, that means you're looking for distance. And we have two equations that solve for distance. It could be d equals st, distance equals speed times time, or it could be distance equals 1/2 at squared. And again, the differentiation is going to be acceleration. One of those equations has an acceleration, one does not. If you do not have an acceleration, you use the speed times time. If you do have an acceleration, you have to use the 1/2 at squared. Now, where it gets a little tricky is the how long. How long means you're looking for time. This is where it can get a little dicey. We do not really have any equations that solve for time directly, except for the speed equation. We already wrote it down. If time equals distance divided by speed. Yeah, we said that. And that's going to be a no acceleration equation. But you could also use v equals at, because if you had a velocity and acceleration, you can use algebra to get the time by itself. And you could also use d equals 1/2 at squared. Again, if you had an acceleration and a distance, you could algebraically manipulate for the time. So time, technically, has a bunch of equations that you could solve for it, and not really any of them solve directly for time. So how are you going to know which equation to use? It's going to come from the list of variables. But let's finish this out first. When a question says, what is the acceleration? There's three equations. It's the three acceleration equations. Acceleration equals final velocity minus initial velocity divided by the time. Sure, that one solves for acceleration directly. You could also use v equals at, which technically is the same equation, but we don't need to get into that now. Again, if you had a velocity and time, you could algebraically manipulate it to get the a by itself. And same thing with this equation. D equals 1/2 at squared. So when we read a question, how fast, how far, how long, what is the acceleration? These things are going to indicate what we're looking for. But they alone no longer tell us what equation we use. We now have to think and use additional information to figure that out. So we're going to walk through several questions and see what we can do. This always comes down to the list of variables. How fast? Okay, it says how fast. That means I'm looking for either speed or velocity. But I don't know just from the words how fast, so I'm going to keep reading. How fast is a train moving that covers 80 meters? Okay, 80 meters. 80 meters. Oh, 80 meters is a distance. So I'm going to write d equals 80 meters in 23 seconds. Oh, 23 seconds is a time. Ah, okay. So I don't see any mention of acceleration here. I see no indication of it speeding up, slowing down. So if you don't see it, it's safe to assume it's not there. That means I'm looking for speed, because how fast without an acceleration is speed. That's it. That's our list of variables. That's how I figured it out. I read through the problem, I saw the absence of an acceleration, and because there was no acceleration, I knew I was using a speed equation. I knew it's going to be speed equals distance over time because I'm looking for how fast, and this is the equation that solves for speed, which is how fast. 80 divided by 23, And again, simply typing this in the calculator, you get 3.48 rounded. Speed equals 3.48 meters per second. Okay? All right, another how fast question. Okay, so how fast does a cheetah go that accelerates from rest? Oh, and I see the m/s squared. I see the m/s squared. Okay, that is obviously an acceleration. So when I see the acceleration present with the unit m/s squared, please don't mistake this for a speed. Students will sometimes not pay attention to that square. The square means a lot. The square doesn't mean you square anything. It just is part of the unit. It is indicating an acceleration. 2 seconds. So t equals 2 seconds. All right? So I have a and t. And when it says how fast, and I have an acceleration, that means I'm looking for a velocity. Here's my list of variables. So I have to pick out an equation that has all 3 of those variables present, and that would be this equation. I have the a, the t, and the v. It's all right there. Let's solve. The velocity is going to be positive 12 meters per second. So again, we just went through both how fast equations. One had an acceleration, one did not have an acceleration. Now, let's go ahead and examine how far equation. How far? So, okay, how far? When it says how far, I know I'm looking for distance, okay? Distance equals question mark. Does a carriage go if it strolled plus 2 meters per second? Oh, that's interesting. Plus 2 meters per second. When I see a plus 2 meters per second, I think that's a velocity. And technically, you're right. It is. But I'm going to hold on for 1 sec here, because I know it's going 8 seconds. Do I see an acceleration anywhere indicated in this problem? No, there's no acceleration. There's no unit for acceleration. It doesn't say sped up. It doesn't say accelerated. It's not here. In the absence of an acceleration, we are going to just use speed. Even though it's giving me a velocity of plus 2, if I took away the plus, I get the speed. So I'm going to say the speed is just 2 meters per second. So don't let a plus mess you up too bad. Remember, I did say back in the day that velocity is speed is distance over time, and I said velocity is distance with the direction over time. So it's really the same thing. So we are looking for a distance, and we have no acceleration. But I know that distance equals speed times time. These symbols match perfectly what I have. Distance equals 2 times 8. Distance equals 16 meters. Nice. Okay, well, what about this? This one says how far. Again, when it says how far, I'm looking for a distance. So distance equals question mark. Does a bird fly that accelerates from rest? Once I see that word accelerates, little buzzer should be going off your head. Okay, I know what equations I'm going to use. So I'm going to say plus 4 meters per second squared. That's the acceleration. For 5 seconds, 5 seconds is a time. So I got DAT. I got DAT. Because there's an acceleration, I know the only distance equation that I can use if there is an acceleration is d equals 1/2 at squared. I want to go over a few math things here because I think some people have been messing up the math. First I'm going to do is just plug into the equation. D equals 1/2. The acceleration I'm going to use is 4. And again, when plugging into equations, don't put the units. And another thing, don't think that this square here means you square the number. It doesn't, it's just part of the unit. The only thing that we're going to square is it when it's in the equation itself, not the unit. So in this case, the only thing we're going to square is the time. You must remember order of operations. Please do not multiply 4 times 5 and then take the square of 20. That would be wrong. You have to do order of operations. So order of operations says we're going to do exponents first. 1/2 times 4 times 25. 5 squared is 25. Awesome. And now I'm just going to multiply this line straight across. 1/2 of 4 is 2. So when you see this 1/2, you can think about it in just 2 ways. You can think about it as divide by 2 or times 0.5. But either way, it's the same thing. 1/2 of 4 is 2. 2 times 25 is 50. Just type in your calculator at that point. This bird went 50 meters in 5 seconds. Nice. But the questions still do become more complex. This one says how long. When it says how long, we're looking for time. So I'm going to write t equals question mark. Just got to know that. How long will it take a biker to end up moving 14 m/s if he accelerated from rest plus 3 m/s squared? Well, when I see 14 meters per second, that's a velocity for sure. And I know I can use velocities because I also see an acceleration that goes with it. So I want you to think holistically as you read a problem. I want you to think about what things are in relation to the other things in the problem. So I have a velocity of positive 14 and an meters per second, an acceleration of 3 meters per second per second. So how am I supposed to know what equation to use? I have a t, I have a v, I have an a. The equation that I have to use has to have all 3 of these symbols. There is only one equation that has all 3 of those symbols, and it's this one. V equals AT. But that doesn't solve for time. I know, and that's okay, because we can use algebra to solve it ourselves. Let's see. Well, velocity is 14, so where it says V, I'm going to put in plus 14. Where it says A, I'm going to put in plus 3, and the t is going to remain the variable. So I really have 14 equals 3t. So to get t by itself, I have to divide. If you divide both sides by 3, 3's in front of the t cancel out, I'm left with t equals, should be 4.67, rounded to 2 decimal places. Perfect. So even though we didn't have an equation that directly solved for time, we were able to identify our variables and pick an equation that matched the variables perfectly. This is why the list of variables is so important, because this next equation that also says how long might not be approached the same way. This question says how long. How long means we're looking for time. Will it take to move 60 meters? Well, that's definitely a distance. That's no problem. No ambiguity about that. If you are traveling 7 meters per second, 7 meters per second, well, that's a speed. Not a velocity, there's no direction. Oh. I see no mention of an acceleration. I don't believe there is an acceleration. And if there's not an acceleration, we're going to use one of the speed equations from the speed triangle. One of the no acceleration equations would be time equals distance divided by speed. Time equals 60 divided by 7. And when I type that in my calculator, I get 8.57 seconds is the time. With no acceleration, we still use the speed equations. How long? Still looking for time. Still looking for time. How long will it take a fish to swim 12 meters? Okay, 12 meters. Okay, it's not too bad. That's going to be a distance. And if 12 meters is a distance, 1.2 meters per second squared, and it says accelerates, I probably should have put a plus there, but that's okay. I know what some people are thinking. Some people are thinking, 10, answer's 10, Bizzuto, you got this. Pay attention to the math. We have a T, a D, and an A. There is only one equation that has a T, a D, and an A. So if I look at all my equations and try to match up these three variables perfectly, this is the only equation that has all three of those variables. But it doesn't solve for time. That's okay. We know algebra. So what we're going to do is we are going to plug in to this equation. The distance is 12. 1/2, 1.2 t squared. Oh, okay. I don't know what to do from here. Well, multiplication is commutative. So I'm going to just take half of 1.2 first. 12 equals half of 1.2 is 0.6. You just type 1.2 in your calculators and you divide it by 2, you get 0.06 equals t squared. Okay. I want to get the t by itself. What do? First, you need to divide both sides by the number in front of the t, which is called the coefficient. So if I take 12 and divide it by 0.6, I get 20. Equals t squared. Am I done? Not yet, because I'm not looking for t squared. I'm just looking for t. So to get t by itself, to get rid of the square, you've got to square root that jump. And when you square root t squared, you have to also square root 20. And you're going to get 4.47 seconds equals the time. 4.47 seconds equals the time. We picked the equation that had all the three variables that we had, we subbed it in, and we solved. What is the acceleration? What a great question. What is the acceleration? So we're looking for acceleration. Acceleration equals question mark. Of a bus that was moving plus 4 meters per second, and after 6 seconds, okay, that's definitely a time, ended up moving plus 12 meters per second. Okay, for now, for simplicity, we have two velocities. And right now, we only have one equation that deals with more than one velocity at a time. So a simple little trick for right now is that if you ever see multiple velocities, we know that we're going to be doing a final velocity, initial velocity equation. So what does that look like? Well, if the bus was moving plus 4 and ended up moving 12, I would say that the final velocity is plus 12. The initial velocity is plus 4. Nice. So our equation is going to be acceleration equals final v minus initial v over the time. Man, that was a straight line. That's awesome. Acceleration equals plus 12. I'm going to keep the signs here because if they ever get negative, I just want you to know to keep them. Minus positive 4 divided by 6. 12 minus 4 is, of course, 8 over 6. And when I have 8 over 6, it's actually really simple. Just divide, and you get the acceleration is 1.33 meters per second squared. In case you haven't noticed, I like rounding to 2 decimal places. Simple. Okay. What is the acceleration? All right, here we go. Let's mark this up. What is the acceleration of a bus that started from rest and ended up moving positive 10 meters per second after 6 seconds? Okay, so we're looking for the acceleration. Acceleration equals question mark. Thank you. The 6 seconds is, of course, the time. And 10 meters per second positive, that's a velocity. I'm dealing with acceleration, so I can have a velocity. Okay, all right. So I have A, T, and V. Okay, interesting. I have A, T, and V, so I could use V equals A, T. Let's just plug this in. 10 equals A times 6. So I'm going to divide both sides by 6. And when I do 10 divided by 6, I get 1.66, or 67, excuse me, if I round, it's going to be 1.67 meters per second squared is my acceleration. Awesome. But wait. Is this the only equation you could use for this question? Actually, no. You may have remembered that I said the word from rest. And I said right now we're only doing the from rest acceleration equations. So if ever a problem doesn't start from rest, there's going to be a different set of equations. I also said that from rest meant the initial velocity was 0. So could I use the A equals final velocity minus initial velocity over time equation as well? Well, let's see. It says ends up moving 10, so that 10 is obviously the final velocity. If the initial velocity is 0 because it's at rest, 10 minus 0 over 6, or 10 over 6. Oh my God. Either way, I get the same answer. Because these two equations are fundamentally the same equation. This equation, though, can only be used when it says from rest. And as of right now, that's all we know. So just kind of showing you multiple ways to think about a problem. Nice. Okay, what about this then? So are you saying that those are all the equations we use for acceleration then? Absolutely not. Because if it says, what is the acceleration here? I'm going to write A equals question mark. What is the acceleration of a llama that went 20 meters? 20 meters is, of course, a distance. After accelerating from rest, so we know there's an acceleration, because, well, we're also looking for the acceleration. From rest, okay, you said it was always going to be from rest, so that's fine. 5 seconds. 5 seconds is a time. Oh, I have ADT. So I have an acceleration, so I've got to use one of the acceleration equations, obviously. And only one acceleration equation has a distance. So we must use d equals 1/2 at squared. Please do not call this an initial velocity, a final velocity. Meters is a distance. That is a very common mistake. I just want people to be aware of that. So what I'm going to do is I'm going to plug in. 20 equals 1/2 a5 squared. Nice. I just plug the numbers in. Let's see what we can do. Well, order of operations is what I can do. I'm going to bring everything else down, except for the exponent. I'm going to square that 5. 5 squared is 25. Nice. Okay, well, what do I do now? Algebraically, multiplication is commutative, which means the order in which I do it doesn't matter. So I can take 1/2 of 25 and not have it be a problem. If I do 25 divided by 2, or 25 times 0.5, or however you want to think about it, I'm left with this. 20 equals 12.5a. I took half of 25. Then, to get the a all by itself, I have to divide by the coefficient of the variable. That's gone. And when I type 20 divided by 12.5 in my calculator, I get 1.6 meters per second squared is my acceleration. That's it. That is an example of every possible permutation that we know currently of the from rest acceleration equations. If you break it down, if you think about the words, if you identify your variables and cross-examine it with your units and your equations, it will become obvious which one should be selected, and then you will use your algebra skills to solve. It is, in fact, that easy. Good luck, and don't forget to like and subscribe.